Usually, software used for A/B tests handles all the calculations that are necessary to interpret the test. And most probably you will have an analyst or a statistician in your organization that is in charge to make sense of the results that come out of the test. As a manager, it's important that you understand the basics of what is given by this software so you can make the proper decisions and understand when to reject or accept the test. It's important that you can engage in a conversation with the analyst or the statistician so you can actually make sense of what is happening and you can make the right decisions. Let's look at the example that we saw before, in which we had this A/B test made of a blue banner and a red banner. Let's say that the banner A, say the red banner that we saw in the previous example, got a click-through rate of 15% with a confidence of 2.1%. Remember that the click-through rate was the amount of people that saw the banner and actually click on the banner. On the other hand, the blue version of the banner, so the B version, got a click-through rate of 18% with a confidence of 2.8%. How do we make sense out of these values? The first thing that we have to look at is the lift. The lift is the difference between the treatment and the control group. As we saw before, the click-through rate in the treatment was 18%, that's the blue banner. The control group, that's the red banner, was 15%. So the difference is 3%. Percentage-wise, this is an increment of 20%. Now you might think this is great. We got a 20% improvement of the click-through rate between version A and version B. So let's go with version B. But this is where we have to look at the confidence that we got. You might think that the 20% lift that you got between the treatment and the control is enough to go for the blue version. But this is where you have to analyze what is the impact of the confidence. Recall that the confidence of the treatment was 2.8%. The confidence of the control group was 2.1%. What this means is what is the probability that if you repeat this experiment, say 100 times, 1,000 times, that you see this very same result. And what the confidence is telling you is that you're going to see this 2.8 times in 100 trials. So it's not exactly the error of the measurement, but is the probability of this experiment being correct. And this is important to keep in mind. What is the interplay between the lift and the confidence interval? The smaller the confidence interval, the higher is the probability that the result that we got from our experiment is correct. For this reason, if we have a really high uplift or lift, then we can, with confidence, go and implement the version B of the experiment. That's the treatment. If the confidence were large, this value that we got, instead we have a 2%, say we got a 10% or 20%, then we might be at risk. Because if we change and the experiment actually goes wrong, we might actually lose. To conclude, we need to let the experiment run until we have a sample size that is representative. When this is the case, the confidence that we obtain is really representative of what is actually happening in our experiment. Interrupting the experiment too early might cause us to have a really high confidence when we are not really that confident that that's an appropriate result.